All right, guys, we're moving on to 8.2, which is multiplying binomials by binomials. I can multiply binomials by binomials and then simplify the expression. So we're actually going to begin to build that quadratic equation that we're going to be actually focusing on from here on out. Again, this is not going to be any more complex than what we've done before. It's just maybe a little bit different than what we've done before. And again, this is going to really set a foundation for what we're going to be doing maybe in chapter 9. Hopefully we can get that in before the end of the year. If not, you'll see it definitely a lot in Algebra 2 as chapter 4. So again, we're just trying to build some things here that are going to work for us from here on out. So let me start with something a little bit simple. So say we had 5 times x minus x plus 8, sorry. So you would tell me here, based on what we did yesterday, that one, I have a monomial here and I have a binomial here, which means that there is multiplication in between and that I would need to distribute this 5 through both of these terms, okay? Well, what we're doing here, though, is we are multiplying by a binomial, but we're also starting with a binomial. So what I want you to imagine is what if I had x plus 5 actually here times x plus 8? Well, what would I do? Well, you just told me that I needed to distribute this 5. I need to multiply this 5 through both of these terms. Well, guess what? In order to really do this multiplication, what I really need to do is I also need to multiply this x through both of these terms as well. Okay? So when we're multiplying binomials, the only difference is you're really doing the distributive property twice. Okay, so let's work on this problem then, and I want to do it down here and kind of clean it up a little bit, and I want to show you what we're actually doing. Okay, so what you're doing when you multiply a binomial times a binomial is actually you are just using the distributive property. So I'm going to distribute this x through to both of these terms, and then I'm going to distribute this 5 through to both of these terms. Okay, and then we're going to talk about that in just a second and come up with another name that we could name this. Okay, so what I want you to notice is really what I'm doing here first. The first step, and we'll put this in red, is I'm multiplying this term times this term. Okay, notice that those are the first terms in both of these binomials. X is the first term here and x is the first term here. So really those are the first terms. Okay, next I am multiplying the first term and the last terms. Another way that we could say that is they are the outer terms. Okay, so this x is on this outer portion over here, right? And the 8 is on the outer portion over here. So really we're doing the outer terms, right? This may be coming back to your memory now, I'm not sure. But next we're going to be taking the 5 and we're going to be multiplying that times the x, okay? So if x and 8 out here were outer terms, then what would you call these terms inside of here? Well, if you guessed inner terms, then you're absolutely correct, okay? And then the next one that you're going to do is you're going to take the 5 and you're going to take the 8 and you're going to multiply those two things together. So again, if the red ones were the first terms, then these would have to be considered the last terms, and that's a wild looking color. But what I want you to see is what we call this process is actually foil, okay? So think of aluminum foil, if that helps you to remember that. But that's actually the process that we're going to be using. Again, it's just a fancy name for the distributive property. So let's work through one of these problems. We're going to do this first step, which is the first terms. So x times x. Now think about this. You've got x to the first times x to the first. What does that make? Again, when I multiply exponents, I actually add them, so that makes x squared. So this becomes x squared. Now I'm going to take my outer terms, which are my blue ones. X times 8 would be positive 8x. Now I'm going to take my green terms here, which are 5 and x, or my inner terms. So 5 times x is positive 5x. And then last but certainly not least, I'm going to look at my last terms. So 5 times 8 would in fact be 40. What I want you to think about here and look at is, do we have any like terms? Well, as a matter of fact, we do, okay? We have some like terms right here. we have a positive 8x, and we have a positive 5x right there in the center, okay? So I'm going to just bring down this just like it is, x squared. I'm going to combine these two like terms, so 8x plus 5x would be 13x, and just bring down the positive 40 from there. So here would be my product, my result of my multiplication of multiplying two binomials, okay? The same exact process is used even when you don't have a 1 in front of those x's. So let me show you one of those examples as well. You've got negative 3x plus 7 times 4x minus 1. And again, because these two parentheses are right beside one another, we understand that there's multiplication in between. So I need to multiply my first terms. So negative 3 times positive 4 would be negative 12. X times x would make x squared. You notice how I kind of broke that down into two steps, okay? Now I'm going to do my outer terms, which is negative 3 times negative 1, which makes a positive 3, and the x is just going to kind of come along for the ride, okay? Now I'm going to do my inner terms, which is 7 times 4x, which is 28x. And then last but not least, I'm going to do 7 times negative 1, which is going to be negative 7. And again, what am I looking for? I'm looking for any like terms. And lo and behold, where are those like terms again? Those like terms are right here in the middle, okay? So notice how those like terms come out in the middle. So I'm going to end up with negative 12x squared because I don't have a like term that goes along with that one. These two are like terms, so positive 3x and positive 28x is going to be a positive 31x, and then minus 7 just kind of comes along as well, okay? So this would be our result. Now this last one's going to be a little bit more difficult, but it is definitely something we can do, and it's going to bring a little bit of geometry back to you as well. I know you guys are going to be really excited about that. So I want you to imagine here that you have a rectangle, and the dimensions of this rectangle just happen to be 5x minus 1 and 8x plus 3. Inside of this rectangle, I have another little rectangle right here, which has dimensions of x and 3x plus 2. And your question, what it actually says for you to do is to be able to find the area of the shaded portion. Okay, so everything except this little part right here. So let's think about how do we find the area of a rectangle. Well, if you remember from geometry class, area equals base times height. So I'm just going to take my 5x minus 1 times my 8x plus 3, right? That's going to give me the area of this blue shaded portion. But now I have to subtract out, right? I've got to subtract out this portion here because I don't want to include that portion in my area. So that means I'm going to be subtracting out this area. We'll make that in red, which means I have to multiply the base times the height on those as well, which means that I would take x times 3x plus 2, okay? So let's just work some things out here kind of quickly. Again, I've got two binomials that are being multiplied times one another, so I'm going to do my first terms first. Again, remember FOIL, F-O-I-L, which is just, again, the distributive property done twice. So 5x times 8x is 40x squared. 5x times 3 is 15x. Negative 1 times 8x is negative 8x. And negative 1 times positive 3 is negative 3. And I could just keep right on going. So we're going to have subtract, right? X times 3x is going to be negative 3x squared. And negative x, remember this negative is just like a negative 1. It's going to both of these, right? So negative x times positive 2 is going to be a negative 2x. All right. So now we can combine some like terms. I've got a 4x squared here. I've got a negative 3x squared here. So that makes 37x squared. I have a 15x here, a negative 8x here, and a negative 2x there. So that would give me positive 5x. And the only other thing I have left is this negative 3 that's kind of hanging out here. So negative 3 right there would be my answer. Okay? So again, multiplying binomials times binomials. This one's a little bit more complex a problem. You're going to have one more like that, so I wanted to do at least one example. But if you need any help, make sure to reach out to us, and we'd be glad to try to help you with these problems. Thanks.